These images are going to remind the world that America can do big things. And they remind the American people, especially our children, that there's nothing beyond our capacity. Nothing beyond our capacity.
Massimo Pascale and his crew got to work as soon as President Biden released the first image from the James Webb Space Telescope, the JWST, on July 11. Hello and welcome back to our channel. In this episode, we'll talk about the unexpected discovery no one expected by James Webb Space Telescope. Pascale, an astronomer at the University of California, Berkeley, divided up the work among 14 co-workers using Slack to coordinate. A pinprick-sized area of the sky was filled with thousands of galaxies, some of which were magnified due to the light of a central cluster of galaxies bending around them. With the goal of publishing the first JWST research report, the team got to work examining the image. "We worked ceaselessly," Pascale said. "It was comparable to an escape room." The team uploaded their work to arvix.org, the server where scientists can upload drafts of their publications, 3 days later, only minutes before the daily deadline. It was quite comical that they missed out on being first by 13 seconds, Pascale added. The winners were Guglielmo Marler from Durham University in the UK and his colleagues, who examined the original JWST photograph. Marler stated that it was a pure delight to be able to publish these excellent facts. Why wait if we can do it quickly? Days after scientists began getting data from the eagerly anticipated infrared sensing megatelescope, the healthy competition, as Marler describes it, underlines the vast volume of information that is already pouring back from JWST. The ability to travel back in time to the early cosmos and observe some of the first galaxies and stars is one of JWST's much heralded capabilities. The telescope, which was put into operation on Christmas Day 2021, is currently 1.5 million kilometers from Earth and has already discovered the most distant and early galaxy known. When two teams independently examined JWST images for the GLASS survey, one of more than 200 science programs planned for the telescope's first year in space, they discovered the galaxy. Both teams, one led by Rowan Naidu from the Harvard-Smithsonian Center for Astrophysics in Massachusetts, and the other one by Marco Castelliano of the Astronomical Observatory of Rome, found two particular distant galaxies in the data. One so far away that JWST detects the light it emitted 400 million years after the Big Bang, Time the galaxy seen by the Hubble Space Telescope is the oldest ever, and the other, dubbed GLASS Z13, seen it as it appeared. It would be the furthest galaxy ever discovered, according to Castelliano. Both galaxies appear to be quite small, perhaps 100 times smaller than the Milky Way, yet they exhibit surprisingly high rates of star formation and have more mass than is typical for the galaxy of their age, 1 billion times that of our own Sun. It even appears that one of the newborn galaxies has a disk-like form. More research will be done to dissect their light and determine its qualities. According to Rebecca Larson, an astronomer at the University of Texas at Austin and a participant in the Cosmic Evolution Early Research Science (CERES) survey, another early universe study has also discovered extremely distant galaxies. Even though Larson and her colleagues haven't yet discovered their precise findings, the team has already collected a few galaxies from the first 500 million years of the cosmos in just a few weeks of the study. "It's better than I had anticipated, and this is just the beginning," she declared. The picture of the galaxy cluster that President Biden exhibited and that Pascale and Marler examined conceals more early galaxies. The cluster known as SMACS 0723 is so massive that it bends the light of farther off objects, bringing them into view. Up to 16 distant galaxies were discovered by Pascale and Marler. Their exact ages are unknown. These galaxies have been enlarged in the image. One distant galaxy in the image, a speck of light that appeared 700 million years after the Big Bang, was examined more closely by the telescope. JWST spectrograph found heavy elements in the galaxies, including oxygen. Now researchers are hoping that the telescope will discover a lack of heavy elements in even older galaxies, which would indicate that these galaxies only contain population 3 stars, theorized to be the first stars in the universe, which are thought to have been enormous and made entirely of hydrogen and helium. Only when those stars burst did they create heavier elements like oxygen and eject them into space. According to the University of Oxford astronomer Andy Bunker, we're hunting for galaxies where we observe no heavy metals. That could be the smoking gun that proves the first stars were made of primordial hydrogen and helium. Theoretically, they ought to be real. It depends on how intelligent they are. JWST has already produced useful data for researchers attempting to comprehend the structure of galaxies and how stars form inside them. One observation program directed by Janice Lee at the National Science Foundation's NOIR Lab in Arizona searches for nascent areas of star formation in galaxies. The young star-forming portions of the galaxy NGC 7496, which is 24 million light-years away, have previously been obscured by heavy dust and gas, which Hubble's detectors were unable to penetrate. JWST studied this galaxy on behalf of Lee's team. JWST, however, is able to observe infrared light that scatters off the dust and allows the telescope to probe very near the times when the stars first begun to burn nuclear fission in their cores, Lee observed. The dust is literally lighting up. The fact that NGC 7496 is a typical galaxy and not a poster child galaxy is what she found most amazing. It suddenly comes to life, though, and displays channels where stars developing when JWST is watching over it, she said. It's really wonderful. While waiting for the JWST to take its first picture, astronomer John Barentine of Arizona's Dark Sky Consulting made a more fortunate discovery. The Southern Ring Nebula, about 2,500 light-years from Earth, was captured in stunning clarity by the telescope. An unusual viewpoint for examining the galaxy's core bulge, a fascinating galaxy that had previously been mistaken for a portion of the nebula itself, peeked into view. According to Barentine, we have this incredibly sensitive machine that will accidentally expose stuff we weren't even looking for. It's worthwhile to look at the background of practically every photo Webb takes. In the upcoming weeks, Malin's program will employ JWST to investigate the cause of this atmospheric heating. The volcanic moon Io, which interacts with Jupiter's aurora to produce a slight bump in the aurora, is hidden in JWST's image of Jupiter. According to Malin, the picture shows material arriving from Io running down the magnetic field lines. The effect has been observed before, but JWST quickly identified it with only a cursory inspection of the planet. JWST is also exploring planets in different star systems. Even though the data is still being processed, the telescope has already seen the renowned TRAPPIST-1 system, a red dwarf star with 7 Earth-sized worlds, some of which may be habitable. Early observation of WASP 96b, a hot Jupiter that is less hospitable and orbits its star in close 3.4-day orbit, has been made public. Water vapor was discovered by JWST in the planet's atmosphere, supporting prior claims of water on the planet made by Chima Magruder of the Harvard-Smithsonian Center and co-workers using a ground-based telescope. But JWST can go farther. By measuring the carbon-to-oxygen ratio of WASP 96b, it could also be able to provide light on the puzzling question of how hot Jupiters manage to maintain such close orbits around their stars. A higher carbon ratio would indicate that the gas giant originally originated in more carbon-rich regions farther away, whereas a higher oxygen content would indicate that the gas giant originally formed close to the star. While doing something that it was not initially intended to perform, JWST may have noticed a transient fleeting phenomenon that is known as a momentary light in the sky. The JWST Operations Center in Baltimore, Maryland, is home to the Space Telescope Science Institute, where astronomer Mike N. Gesser and colleagues have discovered a bright object that was not visible in Hubble's photos of the same area. They believe it to be a 3 billion light-years away supernova or exploding star, demonstrating the telescope's ability to find such events. JWST should be able to discover further far-off supernovas, as well as giving it even another ability to function as a probe of the early cosmos. It may also discover supermassive black holes at the center of galaxies which no other telescope has ever observed, which are capable of tearing apart stars. Ori Fox, an astronomer at the Space Telescope Science Institute who oversees the team investigating transients, said, "For the first time, we're going to be able to peek into these extremely deep black places." The definition of transients and other astronomical phenomena is about to change. JWST has launched into space after years of preparation and building. The challenge right now is keeping up with the steady stream of scientific information coming from a machine that is so flawlessly complicated that it nearly defies the belief that it was created by human brains. It's absurd, but it's working, said Larson. With this information, we conclude today's video. Make sure you hit the subscribe button and leave a like for us in case you liked the video.